So as I was saying, simple chemical reactions, right, are reactions that cannot be easily reversed, unlike a physical change that can be easily reversed. A chemical change is difficult to reverse. And examples are burning or combustion, oxidation, respiration, photosynthesis, and some other ones I'm going to mention to you. You know, for a physical change, you have something like, can you just give me an example?
Of a physical change.
Yes, a physical change.
Melting.
Melting is a physical change because you can change back the liquid to solid, which is freezing, isn't it?
Mm-hmm.
Now, evaporation, you can change it back to liquid, which is condensation. So that's a physical change. There's no chemical reaction that took place in that change or in those changes that I mentioned earlier. But for a chemical change, which involves chemical reaction, it is difficult to reverse. Some are almost irreversible, right?
Mm-hmm.
In fact, a chemical change usually brings about certain effects. I'm going to talk about that. One of those effects is sometimes color change, release of gases, what we call bubbling or effervescence. I'm going to talk about that. Heat change, maybe heat is released or absorbed. It gets hotter or it gets colder, you know.
Mm-hmm.
That's what you find during a chemical change. But for a chemical reaction, there are actually two parts of a chemical reaction. The part on the left hand side is what we call the reactant. Then the part on the right hand side we call the product. It could be reactant if you have more than one. It could be products if you have more than one. An example is this. Are you ready for that?
Mm-hmm.
An example or examples. If I give you oxygen, oxygen plus hydrogen, or hydrogen plus oxygen, will give you water. Do you know that?
Mm-hmm.
All right. What are the reactants?
Uh,
Yeah, what are
that's
the
also hydrogen.
oxygen and hydrogen are the reactants on the left hand side. The product,
Mm-hmm.
only one product is water. Okay?
Mm-hmm.
Let me give you another example. If you can have other examples like calcium carbonate that will give you calcium oxide plus carbon dioxide. Let me write it. I can give you a simpler example. Can I find a simpler example? Okay. Can give you calcium oxide plus carbon dioxide. Dioxide. Carbon dioxide. Carbon dioxide. So what's the reactant in this case? What's the product? Or what are the products? What are the, as the case may be? In this second example, what is or what are the reactants? And what is or what are the products? Go ahead.
It's calcium carbonate, calcium oxide, and carbon dioxide.
Which one or which ones is or are the reactants or reactants?
Oh, calcium carbonate,
Is the reactant. What about product or products?
calcium oxide, and carbon dioxide.
Okay. So the reactants are, as the name implies, the two that combine together. The products are what is formed or what are formed. Okay.
Mm-hmm.
All right. I said something about chemical change. It usually produces certain effects. A chemical change or a chemical reaction let me zoom it in so I can write it better. A chemical reaction produces certain effects. I mentioned them. Do you remember?
Okay, wait, what?
A chemical reaction produces some effect. I mentioned them. Do you remember? I mentioned certain effects that chemical reaction produces.
I don't know.
Okay, I will remind you. A chemical reaction produces effects such as A, you have color change. Did you remember when I mentioned that?
Mm-hmm.
B, you have change in temperature. It might get hotter or cooler. You can have bubbling of gases or what we call effervescence. That gases bubble out, right? Gas bubbling out, bubble. We call that effervescence. Okay. You may even see,
Hello?
yes, I just told you effervescence, bubbling of gases, color change, change in temperature, change in color, and many other ones. All right, go to the next page. I want to give you some of the types of chemical reaction. I'm on the next page. So these are the different types of reactions. Okay? The different types of reactions. The four main types are synthesis. When we synthesize something, we build it. Like to synthesize means to build something, like two things or three things joining together to form something.
Oh.
Like combination. For instance, A combined with B to form AB. Synthesis, to build. Like photosynthesis. Do you understand?
Mm-hmm.
So A combining with B to form AB is a synthesis. Now, when something splits or breaks down, we call that decomposition or analysis. For instance, AB breaking down to form A and B separately. Can you see that?
Mm-hmm.
Then we have another example, what we call substitution. You know, like in a football match or any of such related games, when a player is substituted, the player is being replaced by someone else, isn't it?
Mm-hmm.
A and B are together, plus C to give AC plus B. What did you notice?
The B switched with the C.
Pardon?
The B switched with the C.
You mean the C knocked out B and joined itself with A to become AC, and then B is now replaced. Just like in a match, A and B, just think about it, A and B were together in the match. This is a team AB, team AB. I mean, they were together in a, think of this kind of tennis that two players play on one end and the other two players on the other end. What's the name again? Have you played a sport like that before?
Mm-hmm.
Two players are competing against another two players on the opposite side of the court. You know, if AB are in the same team, now C is like a substitute. Eventually, if C now replaces B, the team will now be AC and B is now rested. That's what we call substitution. Does it make sense?
Mm-hmm.
That's actually single replacement, which is also called substitution reaction. You can also have double replacement, which we call metathesis. You know, AB were in the same team, CD another team. Now they swapped players. C comes to A and form ABC, AC. While B goes to D and forms BD. So it's like a double replacement. What's another name for double replacement?
Metathesis.
Metathesis. So let's mention the ones I have described again. Number one.
Direct combination or synthesis.
Or synthesis, which is like building. A and B build up to form AB. By the way, what are the products? What are the reactants? Or what is the product and what is the reactant in this number one?
AB.
I want to understand what you mean. Can I have the reactant?
Product is A plus B.
The what?
The product is A plus B.
Do you mean the product is
sorry,
A?
sorry.
Can you take that again? Take that
The
again.
product is AB.
The product is AB. You need to be more audible. The product is AB. What are the reactants?
The reactants are A plus B.
The reactants are A and B separately. All right. That's direct combination or synthesis. Number two, what did I call that?
Number two, called it analysis.
Or decomposition, which is like breaking down. Right?
Mm-hmm.
Splitting. A and B split to form separately A and B separately. Then I told you about single replacement or substitution. AB were together initially. C was like a substitute. Eventually, C replaced B, and B now was rested. So you now have AB together plus C will now give you AC together plus B. So B is now rested. C has substituted B. That's single substitution. And of course, I told you about double replacement. I mean, the first one is substitution, which is single replacement. Then I told you about double replacement, which is metathesis. AB together plus CD together, they swapped players. All right, the other types. Are you listening?
Mm-hmm.
well, I should have told you about oxidation first before reduction. Though some of these ones you may not do them at this point. So let me just add them before I talk about oxidation reduction. So I can talk to you about oxidation before reduction and then oxidation reduction. Oxidation, you have oxidation, you have reduction, then you have oxidation reduction. So I can call this number 5, number 6, number 7 now, 8, 9. There are even other ones like hydrolysis, isomerization, but they are beyond your scope. So oxidation is a reaction that requires the addition of oxygen. There are many other ways to define it, but for your level, you can just think of oxidation as addition of oxygen. As what?
Addition of oxygen.
So an oxidation reaction is addition of oxygen. Something like A plus oxygen to give you A oxide, you know. All right, I'll write the examples. Just addition of oxygen. I'll give you the example. Reduction is removal of oxygen or addition of hydrogen. So reduction, I said, is removal of oxygen or addition of hydrogen. Addition of oxygen, I could have added this one, or removal of hydrogen. There are many other ways to define it, but for your level, it can be defined in terms of electron transfer, which is beyond your scope. So let me just leave it like this. The other ones will be dealt with at a higher level. So reduction is addition of hydrogen. For your level, we leave it like that. When you get to higher classes, there's what we call energy electron transfer, or even a change in oxidation number, but that's beyond your scope. Okay, so oxidation reduction is where you have the two of them. Oxidation reduction is where you have the two of them, okay? Where you have the two reactions taking place. You call that oxidation reduction. The two together, oxidation reduction. Then there's acid-base reaction, where acid combines with base. Acid-base reaction. And then there's combustion. Combustion is about burning, right? Burning, combustion. In fact, combustion is the technical term for burning. It's combustion or burning. All right, this last 5, I just want to go through them again. Oxidation, I said, is what?
Oxidation is addition of oxygen.
When oxygen is added, or addition of oxygen. Reduction, for your level, is?
Addition of hydrogen.
Then you have oxidation reduction, or redox, which is the two of them happening at the same time, okay? In oxidation, oxygen is added, reduction, hydrogen is added, you know, all occurring at the same time. Or electron is given and the other one loses electron, as the case may be, for higher level. Acid-base reaction is when acid reacts with base, usually to form salt and water, what we call neutralization reaction. Combustion is burning. Okay, so let's look at some of the examples of all these I mentioned. Examples. Are you ready for that? For synthesis, which is direct combination, an example is something like iron plus sulfur to give iron sulfide. Did you see that? Did you see that the iron is combining with sulfur? because synthesis is like two things coming together to build up and form something bigger. Iron combines with sulfur to form iron sulfide. Did you see that? Then for decomposition, I told you decomposition is like breaking down. Water breaks down and forms hydrogen and oxygen. Does it make sense? Now there's substitution.
Actually, wait, can you explain that again, please?
Good. Look at water. The water now splits into two. One part hydrogen, the other part oxygen. It's just like what I explained here. Analysis or decomposition. Like AB, the two were together as a team. Now they separated. They went solo. You get that? Like in music, we could say they were doing a collabo together, and then eventually they went solo. A and B are now separately performing their art. That's decomposition, breaking down. Different from analysis. In fact, analysis is the opposite of synthesis. Why synthesis is about building, joining together to form a collabo. Analysis is splitting or decomposition. Did you get that? Okay, so let's look at replacement, single replacement. An example is zinc plus hydrochloric acid will give you what?
Zinc plus hydrochloric acid will give you zinc chloride.
Will give you what?
Zinc chloride.
Read it fully now.
Oh, it's on there. Zinc chloride plus hydrogen.
What did you notice here? Can you compare it with the original thing I told you? What did you notice?
Did the hydrochloride change or something? I don't know.
You know, in single replacement, something is replaced, substituted. Look at it again. Zinc plus hydrochloric acid.
Oh, the chloride was moved from the hydrogen and put next to the zinc.
Exactly. The chlorine was replaced by zinc. The chlorine was replaced by zinc, and hydrogen is knocked out. As it were, hydrogen is no longer in the combination. Hydrogen is taken out. Did you see that? Next is an example for metathesis or double replacement. What I have here as an example is sodium chloride plus silver nitrate will give you sodium nitrate plus silver chloride. What did you notice?
The nitrate, the chloride and the nitrate switch sides.
Correct. That's what we call double replacement. Sometimes it is also called double displacement. Displacement, to displace. This first one can also be called single displacement, or what we call displacement reaction. This one is single displacement reaction. The second one is double displacement reaction. You know, I told you oxidation is addition of oxygen, right? I can give you an example for that. Something like sodium plus oxygen equal to sodium oxide. Sodium plus oxygen gives sodium oxide. What happened? What did you notice? Compare it with the definition to see if you can get what happened here. Yes.
Is it oxidation and reduction?
No, I'm talking about, you see, what did I say about oxidation?
The adding of oxygen.
That's exactly what happened here. Sodium collected oxygen to become sodium oxide.
Oh.
That's what happened.
Oh.
Right? Look at this one. This first one I gave you here can also be used as an example for reduction. This first one I gave you, if I write it differently, hydrogen. Okay, let me put it differently. Chlorine plus hydrogen. Let me use a different one. I think I need to zoom it in to write it better, and I'll get it back again. Read the example I've written now. Go ahead.
Chloride plus hydrogen.
It's not chloride.
Chloride plus hydrogen equals hydrogen chloride.
Okay, what happened? I think the better way, you could say hydrogen plus chlorine in any other, the same thing. Or let me leave it the way I wrote it. Chlorine plus hydrogen equal to hydrogen chloride. So what did you notice there?
Is it reduction?
Why is it a reduction?
Because there was the adding of hydrogen.
Because there's an addition of hydrogen. All right. The next one, number 8, is acid-base reaction. We can think of sodium hydroxide, hydrogen chloride or hydrochloric acid. Hydrochloric acid plus sodium hydroxide. Okay. Hydrochloric acid plus sodium hydroxide gives sodium chloride plus water. This particular case is what we call neutralization reaction. The first one is an acid. Can you see the one I circled? While the second one is a base. So acid combining with base to form what we call salt and water is what we call neutralization reaction. So a special example is e.g. neutralization reaction. Neutralization reaction, right? So what's the neutralization reaction?
Is it neutralizing a reaction?
So what is it about? A reaction involving acid and base to form salt and water only.
Oh, okay.
Right? So what did I say is a neutralization reaction?
Neutralization reaction is an acid and a base forming to make salt and water.
Okay, acid plus base to form salt and of course water is a neutralization reaction. Acid plus base to give salt and water only is a neutralization reaction. It's also another type of reaction. Then of course there is combustion or burning, like when something burns, like methane plus oxygen to give carbon dioxide plus water, right? These are the different types of chemical reaction. Let's run through them again. Just read them out. Number 1.
Oxidation. Wait, which one? The ones at the...
You can start from the beginning. Let's run through them.
Okay. Direct combination.
Which is also called
synthesis. Analysis, which is also called decomposition. Substitution, which is
substitution.
Substitution, which is also called single replacement. And metathesis, which is also called double replacement. Oxidation, which is the adding of oxygen. Reduction, which is the adding of hydrogen. Oxidation plus reduction is when both of them happen together. Acid and the base.
What's another name for oxidation, reduction?
Or redox.
Redox, okay.
Acid and base, which is also neutralization reaction.
And of course you have
combustion of
burning. All right. And then of course we gave examples for each, right? All right. Go to the next page. Okay, you are there already. Whenever you see something like IDE, it means 2 elements are involved. An example is calcium oxide, which of course means calcium plus oxygen. Calcium oxide. So take note of that. Anytime you have 2 elements involved, then you have to add IDE to it. Okay, let me give you another example. So I will just write examples. You have aluminium and chlorine. So aluminium plus chlorine should give you what?
Give you, I don't know.
Yes, I just
aluminium chloride.
Good, aluminium chloride, because when you have IDE, it means 2 things are involved. So aluminium chloride, because 2 things are involved. Iron plus sulfur should give you what?
Sulfuric iron.
No, you mentioned, oh, I like that. But you mentioned the metal first before the non-metal. I should have told you.
Iron sulfuric.
Say that again.
Iron sulfuric.
Remember I said the 2, when the 2 are involved, there should be IDE at the end. So iron plus sulfur should give you what?
Oh, iron sulfide.
So you have iron sulfide. When 2 are involved, you have IDE. Okay?
Okay.
Let me give you another example. Iron sulfide. Okay? What other example can I give you? Potassium plus chlorine should give you what?
Pardon, what plus chlorine?
Potassium plus chlorine. Potassium plus chlorine should give you what?
Potassium chloride.
You don't need to do anything to the first element, just potassium then chloride. Okay,
Okay.
potassium chloride. Remember I said two things are involved. The two elements combined, two elements. Then you have the IDE, right? Now, when you have ATE, ATE, ATE means there are three elements, one of which must be oxygen. And I will give you an example. I said ATE means three elements. One of which, or one of them must be oxygen. One of them is oxygen. I will give you examples. Are you ready? Examples are aluminum carbonate, how many elements do you have in this aluminum carbonate?
3.
What are they? There are 3, yes. What are they?
Oxygen,
Yes.
aluminium,
Yes, oxygen, aluminium, and
carbonate.
carbon.
Carbon.
The ATE is telling you that there are 3. So oxygen, aluminium, and carbon, okay? So this is for oxygen, aluminium, and carbon. Can we take another example? Calcium sulfate. What are the elements that are here? Buddy, how many elements?
3.
So what are they?
Oxygen, calcium, and sulfur.
Oxygen, calcium, and sulfur are involved. All right. That's that. In summary, I said unlike a physical change that can be easily reversed, a chemical, go to page 5 of 7. Unlike a physical change that can be easily reversed, a chemical change cannot be easily reversed, right? A chemical change cannot be easily reversed. Go to, yes, you're there. And it's difficult to reverse. Examples are burning, oxidation, respiration, photosynthesis. Like when you burn a piece of paper, you can't easily, in fact, you can't even gather the ash to get back the piece of paper. It's not possible. And in a chemical reaction, the elements on the left-hand side are reactants. The ones on the right-hand side, separated by an arrow, are products. Examples: hydrogen plus oxygen equal to water, and then you know the reactants, and then the product. And a chemical reaction usually produces certain effects like color change, change in temperature, gas bubbling out, like oxygen coming out, hydrogen coming out, chlorine gas coming out, oxygen gas coming out. And then the next page, I told you about the different types of chemical reaction and examples, right? And then, of course, we also talked about some of the names that you find when certain elements combine.